So hey guys, welcome back to my channel The Math Sport. So in last videos we have discussed about inverse circular functions and what is complex numbers and some of its properties. So today we are going to study about conjugate and its modulus of a complex number. So first, what is the conjugate of a complex number? So if we have z, which is x plus iota y, is any complex number, then the complex number x minus iota y is called conjugate of a complex number. That is, if we have z as a complex number, then z bar is its conjugate and its sign will be changed from plus to minus. Okay, so thus if we have z is equals to 3 plus 4 iota, then what will be its conjugate? So we will find its conjugate now. So what is it? Its conjugate is 3 minus 4 iota. So this is the conjugate of this z. Okay, so if we have z is equals to x plus iota y is any complex number, then we will define its mod z, which is equals to under root x square plus y square. Obviously we can write mod z is equals to z bar mod. So there are some results that we have to obviously remembered. So first one, so we have some following results. So first result is, if two complex numbers are equal, if and only if their conjugates are equal. It means that if we have two complex numbers, then if their conjugates are equal, they can be equal. That is, z1 is equals to z2 if and only if z1 conjugate is equals to z2 conjugate. And the second property is that conjugate of z conjugate is always z. So we have to remember that if we have z conjugate, then we will write it as z. Third is four properties: addition, subtraction, multiplication and division. Here we will use that if we have z1 plus z2 conjugate, we will write it as z1 conjugate plus z2 conjugates. Similarly, we will write for negative, for multiplication, for division also. So here z2 is not equals to 0. So next, fourth property, if we have z is equals to x plus iota y, then the addition of z and its conjugate is always twice of real part of z. Okay, so for if z is equals to x minus iota y, then z minus z conjugate is always twice of its iota into its imaginary part of z. So our sixth property is, if a complex number z is purely real if and only if z minus z conjugate is always equals to 0. Property seventh, if a complex number z is purely imaginary if and only if z plus z conjugate is equals to 0. And our last property is, the product of z and its conjugate is equals to x minus iota y. When we will solve it, we will get x square plus y square. So here is a note that the product of two conjugate complex number is a purely real number which is always greater than 0. That is, which is never negative. It cannot be negative. So our next topic is modulus of a complex number. So what is the modulus of a complex number? So its definition is as follows. If z is equals to xy, which is in ordered pair form, or x plus iota y be any complex number, then the non-negative real number under root x square plus y square is called the modulus of a complex number z, or we can call it absolute value of a complex number z. It is denoted by mod z or mod of z. We can write it like this or this. So now what is it? Here is x is 3 and y is 4. So we will write under root, what is 3 square plus 4 square. Then what is under root plus 16 is equals to, so how we can find the modulus of a complex number? We will just use it like mod z is equals to under root x square plus y square. Okay, so we have the following results about the modulus of a complex numbers which you should be remembered. So first is, if z is any complex number, then mod of z is equals to conjugate z mod. So we can write it like, if we have z as x plus iota y, then it will be under root x square plus y square. But if we have what if we have mod z equals to mod of x minus iota y, it means this. So how can we write it? Under root x square plus minus y square. So we can write it as then this is comes to mod z. So it means mod z is equals to this. So our next property is mod z is equals to 0. So we know that what is z, x plus iota y. So we will found its mod, which is under root x square plus y square is equals to 0. It means x is also 0 and y is also 0. If and only if z is equals to 0 plus iota 0, which implies z is also 0. So here we have some more properties. The z and z conjugates product is always equals to mod z square, and here the product of two modulus is equals to the product of the moduli, and same here the modulus of a quotient is equal to the quotient of the moduli. Next is if z is equals to x plus y, then what is the real part of z is x, which is smaller than is equals to under root x square plus y, which implies that our z is always smaller than is equals to mod of z, because this is the value of mod z. Okay, similarly we can do it for imaginary part of z, which is always smaller than is equals to mod of z. So here we study about the conjugate of a complex number and modulus of a complex number.